All right. Evening, everyone. Good morning, good afternoon. I mean, wherever time zone you're in and wherever you're joining us from, you are welcome to this webinar session. Just a quick introduction about myself. I'm Najeeb, and I currently work as a data engineer with Jaguar Land Rover UK, which is a vehicle manufacturing company with a global brand here in the United Kingdom. So, and other than that, I'm also the number one servant of this community. So I'm privileged to be the founder of this community. And I usually say it's a privilege because it's not something you will contribute to, and it's beyond myself now. So this is DEC. If you are joining us outside of the community, because I understand some people also join us that are not part of the community. So this is the data engineering community, and this is a community whereby we come together to learn together. Like I always say, it's a platform for all data engineers across all levels to interact together. So it's been a supportive platform for every one of us. And this webinar is a series, which is one of the initiative of the data engineering community as well, called Demystifying Data Engineering Webinar Series. This is something that started January of 2024 this year, and this is the 10th episode of Demystifying Data Engineering Series. And like I said earlier, so it's just an initiative for us to learn from each other and explore different topics in the world of data engineering. So it's open to everybody, not just the speakers. So you are all required to contribute, by asking questions and also contributing knowledge to the topic of today. So today we'll be discussing another very important topic, so which is all about data ingestion with DLT. And the speaker that will be doing justice to that is no other person than Kudus Ayala. Kudus Ayala is an experienced data engineer with experience across finance, retail, and real estate industries. I'm sure we'll be learning a lot from Kudus this evening. I'm very sure of that. We'll be getting to the world of data ingestion with DLT. So you demonstrate how we can leverage this powerful tool, with an open source Python library to design and simplify our data ingestion. Data ingestion is one of the most critical aspects of data pipeline, which is also called data engineering. So it's a sensitive area that we really need to pay attention to and see how much we can optimize and upscale ourselves in this aspect of our data engineering tech stack. So in terms of the program itself, so it's going to be maximum of 2 hours. It would be nice if you can finish before that, but if not, you can accommodate up to 2 hours. So after the presentation by Kudus, so there'll be room for plenty of questions. So, but if you don't want to forget any question you have, you might drop it in the comment section and we'll pick it up when it's time for question and answering. So if you also want to maybe follow along as well, so that is also possible. And every resource is used, we'll get it from Kudus and we'll share it after the call. So Kudus, thank you so much for joining us. Thank you for willing to share with the community. We are always happy to learn and we are super grateful for your time and commitment to sharing with us today. So without further ado, I will leave you to it, Kudus, to take us through what we have for us today. Thank you so much, everyone, for joining once again. Thank you, Kudus. Over to you.
Hello, good afternoon, everyone. Hope you're having a great weekend. Can you all hear me? Can you see my screen?
Yes,
All
yes, I
right.
can hear you. I hear you.
All right. Today I'll be taking you on data ingestion with DLT. So basically, my name is Kudus Hayola. I'm a data engineer. I have 4 years of experience working on data engineering solution, building and maintaining scalable pipeline. I have experience injecting data, transforming it, and make it usable for analytical process. I've had experience with data quality, data management, enterprise data warehouse design, and technical architecture. So today, basically, we'll be covering data ingestion with DLT, how you can extract data from API, normalizing and loading data, incremental load. So basically, and for those people that are new to data engineering, so there's this question here that says, what's data engineers do? So it might appear very simple, but then the major goal of a data engineer is to get data from different sources and do something useful to it and serve it. So it's usually when you get your data, you are trying to do different things on your data, transform the data. You are trying to apply some different data quality rules on your data, standardize your data, and make it available for analytical purpose. So the destination is usually an analytical destination. So as a data engineer, your responsibility is beyond just building and running data pipeline. Your responsibility cut across fixing data pipeline, um, optimizing storage, data quality, data integrity. So in summary, data engineer extend just beyond the mechanical aspect of pipeline development. So it encompasses strategy management, enhancement of data lifecycle. And today, basically, this webinar will focus on building robust scalable pipeline using DLT. Uh, so I'll move to the next slide. So this is saying, what is data ingestion? Data ingestion involves extracting data from source, transforming it into suitable, extracting your data from source, transforming it to a suitable environment, basically. So you can be extracting your data from different sources. It could be from some API, it could be from some web script data, it could be from a different database. And what you are trying to do is you are putting it in an environment whereby you can use the data. So, and after extracting your data, what you typically want to do is normalize the data. You want to occasionally clean up the data. You want to add additional metadata because some data might not come structured. Some data might not have implicit schema, might not have schema defined in it. So this could be your CSV file. It could be some nested JSON file. It could be different file. So why some might have like explicit schema. So your package file can store your schema information. If you are pulling from another database, it stores schema information. So in many data science teams, their data just seems to appear effortlessly. But then who handles all that? The data engineer take charge of loading the data, making the data available for them to use, because usually data in raw form might not be usable because it's of bad quality, is not standardized, is of dirty data. So today we'll be working on how you ingest such data. So what is DLT basically? DLT is an open source Python library for data loading. So, we have different tools for loading your data. We have tools for transforming your data. You have tools for reporting, basically. So this DLT is not, it doesn't do any of those. You are not trying to transform with it. You are not trying to orchestrate your pipeline with it. You are not trying to, what's it called? You are not trying to report with it. What you typically do with DLT is for ingestion of data. So you are pulling your data from source and you are ingesting with DLT. So it's rare for you to come by a specific tool or a specific library that help you handle the entire thing, that help you set up like a custom pipeline that can work with numerous sources for extracting data. So this tool has been developed for loading data. It has been developed for schema management, detecting different data type, scalability, self-healing extraction. It also serves as a comprehensive resource for data engineer, providing best practices. So this tool was developed by Andran Budaru, if I pronounce that right, and other DLT teams. So we move to the next thing, which is pros of DLT. So why is DLT important, basically? So your typical injection pipeline, if you are sought out for using DLT to develop your pipeline, it helps you build your pipeline faster, like 10 times, 5 times to 10 times faster, basically. So it's a self-healing, self-maintaining pipeline with all the best practice of a data engineer. So it also automates schema changes, remove bulk of maintenance efforts. It generally helps you develop pipeline like a senior data engineer. So we will get to that. We'll get to what are the things DLT help you maintain. We'll get to what challenges you might face when you are trying to pull your data from the sources. Because basically, right, lot of times you want to pull data using different API, SQL request API, and just use your Python pandas library or iterate through the data source, load it into a list, and just bring your data into your data warehouse. But what you've been doing might not necessarily be the best practice or might not necessarily be a scalable approach of ingesting your data. So how do you build your pipeline such that it is easy to scale? How do you build your pipeline such that it is easy to maintain? How do you build it faster too as well? So these are the different things DLT can help you handle. So if I move to this now, this is saying the consideration of extracting data. So what do you consider when you want to extract data to prevent your pipeline from breaking and also to help them run smoothly? So running your pipeline, if you're in my last session on Spark, we tried to run a Spark query transformation to pull very large amount of data, but it didn't run. But whenever we are pulling a small amount of data, it runs well. Because basically I'm doing this on my local computer hardware using my CPU and my memory to run that script. But there are situations whereby what the data you are pulling, there are always situations whereby the data you are pulling is way large that whenever you try to extract such data, you run out of memory. So there are usually hardware limits in your computer. So data can limit you in the sense that when the data is too large, you might run into memory limits. You might run into a storage error because it's too large. Then this memory we are talking about are usually your RAM, your virtual memory, your disk or physical storage. So how do you navigate through this challenge of managing memory? So another limitation you can run through is your network limitation. So there might be a network failure whereby you are calling an API to get data, is returning a network error because the API at that point is not available, or the availability of the source system or your resources you are pulling from at that moment, the source system is not just available. So you can run into a network error or a network failure sometimes that prevents you from pulling those data, or whereby you are running your pipeline at a certain time, your pipeline just break because at that point you want to fetch your data, you run into an error. So DLT as a library can provide you with a request replacement whereby there are inbuilt retry functionality for you to handle such data. So whenever you can't access that data and you are getting a network limit, DLT can help you retry that query or retry that script in order to fetch the data you need. So the other thing could be source API limitation, because usually different sources has their limits in terms of the amount of data you can fetch from the website at a particular point in time. So you might run into a request limit. So this is like a rate limit. So basically, you can read through those. DLT can help you overcome such situations too, because if you read through those documentation of where you are pulling from, there is usually a limit or some obstacle whereby it says when you've run your query or when you try to run a fetch query to get data from the sources, it will just run into a particular limit after some time. So this will happen a lot for people that try to scrape data from website a lot, get data from different web API, whereby there are rules on how much data you want to fetch from those websites. So basically for this session, we'll be focusing on majorly the hardware limitation and how you can overcome this hardware limitation. So extracting data without limits, without hitting hardware limitation, basically. So how do you extract data without limits, without hitting your hardware limits? So a lot of data pipeline operates on serverless function. So you could be using your orchestrator. So a lot of data uses data pipeline uses serverless functions or orchestrator like your Airflow that distributes tasks across multiple clusters. So this system have like limits in their memories. Let's say you could be working on like a 4 gig or 16 gig memory or 32 gig memory. So there are limits to those memories. So how do you run your pipeline in order not to like run out of memory? Because when you are working with large data or you are performing a task that involves using a larger memory, you can crash your data pipeline. You can also crash the machine, the pipeline at that particular period in time. So similarly to your disks or your storage too, you can also fall short of your storage when you are trying to load data into into a different data source. And most times it's not a case of you not, what's it called, scaling up. Most times it's not a case of you might scale up, but at one point you can still reach your limit. And during runtime, it's not easy to automatically scale up during runtime, or when we are processing your data, it's quite difficult to want to like quickly scale up during runtime when you have hit your memory limits. So this is saying, how do we avoid filling the memory? So most times data volume is often unpredictable. So we can always scale hardware dynamically, or we can't always scale hardware dynamically or infinitely during runtime. So which means when you are running your pipeline, it's not every time you can easily scale your pipeline, your hardware or your memory dynamically, or your storage dynamically when you are running your pipeline. So the solution is to control the limits or control the maximum memory that will be used. So at a point you want to run your data, you can control the memory that will be used. That, okay, don't exceed beyond this memory when you are trying to pull your data. Don't go beyond this amount of data when you are trying to pull the data from the source. So we'll try to demonstrate this using a Python script whereby you can control this entire thing so as not to like run out of memory when running your data pipeline. Another thing is normalizing your data. So one of the things DLT, okay, one of the things DLT can do for you is help you normalize your data. So usually we have these two parts of data normalization. One is normalizing data without changing its meaning, or normalizing data, filtering the data for just the use case, which changes its meaning. So you can either filter your data for just the use case to change the meaning of the data, or you normalize your data without changing the meaning. So it's different ways of normalizing your data is adding data type. Probably you want to convert to number, you want to convert to date or timestamp, you want to flatten your JSON file, bring nested dictionary value on top of your dictionary row, renaming your column to ensure that the column follows the right standard, such as using no strange character in the name. So there are different ways you want to rename your columns when you are working on your databases or your environment. And on nesting list of arrays. So those are the different ways to normalize your data. So when you are pulling from JSON file format, it is typical for you to want to normalize such data because such data are nested. So why prepare your data? Why not just use your JSON file as it is? So basically, we do not easily know what is inside your JSON document due to the lack of schema. So you don't typically know what is nested within your JSON. It could be that you have a row whereby your age is 25 as in 25, and on another row you have your age as this 25 year, and you have other places where your age is 25 with a decimal. So it could come in different variation, and you are not usually sure of what is inside your JSON. And reading your JSON file, most times we scan your entire data or the entire document into your memory. Unlike working with CSV file, whereby you can always read row by rows, or your package file that is usually a columnar storage, whereby you can read it block by block. So JSON file can be really slow and might cost a lot when you are trying to read it. It's not fast for aggregation. Columnar formats are usually very fast for aggregation, and it's not fast to search, basically. So those are the reasons you want to normalize your data, put it in a structured format whereby you can rename your column, whereby you can change the data type, whereby you can use change your data type. You can pull those nested data from the source system. So we're going to be covering incremental loading too as well, whereby incremental loading is basically the art of only loading new data or data that changes, and not just old record that has already been loaded into your database. So basically, you have historical data in your database. You don't want a situation whereby you are just scanning your entire database or your entire source system to load all data back into this destination system, because it will cost you a lot, and it's usually faster when you are using incremental loading, and it costs less to run incremental loading because you're only bringing new data from your source system. So with DLT, you can also do your incremental loading easily. So the only challenge of the incremental loading is if you can't keep track of the state of your data, or you don't have a column that you can use to load incrementally, such as column like date updated, or column like that has numeric ID that increases for each row. So if you don't have such columns that keep the different state of data, it might be hard to bring in incrementally. So different ways you can write into those databases using full load. Full load is when you are scanning your entire source systems and you are loading it into your destination table. This is not usually advisable, but there are situations whereby you don't have choices but to use full load, probably because it's a data that you can't keep track of the keep track of a column that can help you show the states or show what has changed in your data sets. So if you don't have such column that can help you with that, you can't do incremental load. You have to do a full load. So there have to be like column that help you track the changes within your database. Another one is append. Append is when you try to read data and merge only new record into your database. So you are bringing in just new data. So it could be data whereby it has inventory information, or data whereby people are taking orders for different transactions or different sales that have been made. So for each sales has its unique ID or unique order ID. So whenever new orders come in, you have your data in the source system. What you can do is those new orders, you can easily append them into your destination tables without having to load the entire data set from one set. But merge query basically help you update data that are already in the destination and also help you bring in the new data. So how that works is basically when you have data already in your destination table that stores information on customer, your customer phone number might change, your customer address might change. So merge query can help you look for that customer ID and help you update those records within the destination table and also bring in just the new record. So these are different questions you try to ask when you are trying to bring data incrementally. Number one, is it stateful? Stateful means, does it change or not? Data in the source system, does it change or not? So like I said, if you are dealing with data that has to do with records, that has to do with what's it called, sales that have been made or orders that have been taken, usually each orders are usually unique and it doesn't change. So such data, you can just, at every point you are pulling from the source, you are just appending the new records. So another thing is, can you track changes in those data? If it's a stateful data means a data that change. It could be information on the customer like that I just mentioned. Can you track those changes? So if you can track those changes, you can either use SCD type 2. If you can't track those changes, then you will now ask yourself, can you bring the data in incrementally or not? Incrementally means, do you have a specific ID that increases that you can, a unique ID that increases that you can use to bring your data incrementally? If you can bring your data incrementally, if you can track the changes, but you can't bring the data incrementally, you have to use your merge query, which means what you are trying to do is you are trying to only update new record and bring in the new one. So using that ID, using your customer ID, you can match the data to your destination data in order to update that record. Then in situation whereby you can't bring it in incrementally, probably there's no ID that you need to bring those data incrementally, you can use a replace statement. So let's say you don't have a unique ID for each row, you have to always overwrite such data using a replace statement. So this is asking if you need to track history or not. If you need to track history, it means you can use your STD type to whatever changes you have in your data warehouse, it stores the history of that change. Let's say a customer has a previous phone number and a new phone number. You have your record whereby the first row stores the customer record with the old phone number, and the new row stores the customer record with the new phone number. So those are the different questions you ask when you are writing your data. So let's take a look at a Google Colab notebook whereby I can explain very well how this DLT works. So first thing you want to do is you want to run your DLT. So first thing you want to do is you want to install the DLT library and the necessary dependencies. So like I said before, DLT is an open source data library primarily for loading your data. Primarily use it to extract data from source and load it into your destination table. And there are different reasons why you want to use your DLT, because it's help you maintain your data pipeline. It's user friendly. Basically, it helps you write your scripts or load your data like a senior data engineer. It helps you efficiently extract your data, automate your schema management, help support data governance in terms of schema enforcement, metadata utilization. It is scalable. So right here, what we do is to load our data using DLT. Then the next thing is, this is showing different examples of loading your data. So right here, this is a typical way you might want to load your data. So using a Python generator. So what this Python generator does for you is, at every time, what we are pulling data from New York Taxi API. So it's going to be reading page by page in order to get the necessary data we need. So using a generator, Python generator, usually what it means is it doesn't bring in all record from your source system. The same way you want to request data from API and it will just read all your data, all your files from your store system. The disadvantage of reading a file from source system and injecting into your database is because the file might be too large and you might run into a memory error. So using this approach, we are running our data in micro batches, which is the yield, using the yield statement. Yield statement is like a Python generator Python generator method, which means at every point it's read each pages, at every point it's read each rows of data. It will help you write it out. So right here you can see we have a function whereby it's picking page by page. Then this is a request.get that uses API to get the data needed. Then at every point it's read those data, it yield a JSON file. So this is saying where there is no more data, break. So you understand this very well now. So the generator basically, it iterates your data row by row or page by page and just return each row. It doesn't first load up your data, then read each row. So what it does is from your data source itself, it's load your data and read it row by row. So right here, you can see it's got page number 2 with 1,000 record. Then it's moved to the next one, read the next 1,000 row, move to the next record, read the next 1,000 row. Unlike you trying to read all your data directly from the source and loading it, you can run out of memory. So what this does is this allows you to better manage your memory in terms of the fact that your memory might be really small, but this will allow a good throughput of your data using the small memory that you have. And it's relatively, it might not be as fast as loading all your data, but basically it helps you manage your memory properly and it's easy to scale. So if you move to this one, this is like a bad way of getting your file. This is when you are downloading everything at once. So you can run into the risk of running out of memory. So in case of machine that runs multiple jobs, an out of memory error runs the risk of killing not just your current job and also your machine runtime. So this one here, what this code is doing, basically, this is how most people tend to run their Python script. So what they are doing is they are fetching their data. The data is being returned in a JSON format. So you are running a JSON split line function on your data. Then what you are doing now is you are now loading everything into this list. Then you are returning your past data. So what this is doing is all data are being loaded into this list. So doing this, you are running into a risk of losing your memory. So if we come right here now, you see that at every time you run this, even before you try to print the first 5 rows, it must have loaded all your data into this list before you now print this first 5 rows. So what this is doing is it will wait for all the JSON file to get appended into this list. Then you can now read your first five rows. That means it's loading all your data from the source system. Then you are reading the first 5 rows. This can typically make you run out of memory when you are working with a very large amount of data. So like I said, this one basically, as you read each row, typically this is writing out each rule as you read it. So you can do whatever transformation you want to do for each record. So it's yielding it as it's reading the data source in real time, it yields each row. Unlike this, it loads all the data into your memory before you can now read your value. So far, do you have any question on this?
There is no question on the chat, so I'll advise you move on.
All right,
Get our feedback after the presentation.
Good. Yeah, sorry, I have a question. Am I free
Okay.
to ask? Okay, sorry for cutting you. What platform do you use in running your code? Is it PyCharm, or can we use
This
PyCharm,
is
or we can use
Google Colab.
okay,
You can
Google
use your
Colab.
normal Jupyter notebook. You can
Okay,
use your Python
okay,
script, but for this session, I'm using Google Colab.
okay,
So I can share you link to this Google Colab so you can have access to it and play around with the code, because typically this notebook itself can let you learn this on your own, because it's to some extent it's self-explanatory. So you can go through this and practice with this script.
All right, I'll be delighted to get the link.
Yeah.
Thank you.
Okay, no problem. So another way you can, so best practice, basically most scalable ways for you to like not load all your data, which because you don't know the amount of data that you are bringing in from the source system, it's better to use a generator, Python Python yield method in order to bring in your data, because when the data is too large, it can break your pipeline. So you don't necessarily want to be loading all your data into memory at once. You want to be reading it line by line. Then that way you can be transforming your data on the fly and loading it directly into your destination table. So another way is right here, we are streaming our data in real time using the yield statement. So this basically, whenever the data gets into the destination, it can easily stream the data and fetch the data row by row, basically. So this is the generator function that is reading the data, basically saying for each line, yield this file. So this is not running yet. Doesn't pull the data yet until you call this function here and you take it row by row. So for each of these objects that was being produced by this one, from this object, this then iterate through this row by row in order to pull your data. So this is reading your data row by row from this directly from the sources. So you can see use generator to iterate over row with minimal memory usage. So you are reading row by row, unlike you having to use your return method and using your append to append into a list of value. You stand a chance to run into a risk of running out of memory. So I can go ahead and run this. So we have three ways to download the same data. Let's use a fast and reliable way to load data and inspect those data using DocDB. DocDB. So this is saying basically we are using our DLT now. So what we want to do is this generator, we can pass it into our DLT pipeline. You can use your DLT.pipeline, then pass into create the destination, what's it called, the destination database and the data set name that we want to use. So the data set might as well be like the what's it called, the table name, the database name. Why this might as well be your table name, which is this. So what we are doing is we want to pass that generation function into your DLT pipeline in order to read your data and load it into this DocDB destination database. So DocDB basically is an in-memory database. So what it does is usually is a database that it's consider it as your database that you can use for development of your pipeline or your ETL process and run your SQL statement on it. But underlying that database itself are usually files of your data stored beneath it. It allows you run your ETL, but then is a database that you want to use for development, because it's easier for you to spin your DocDB within your notebook in order to test your pipeline, in order to perform different transformation. So typically it's like your in-memory database. You can, rather than using DocDB, you can always load into your data warehouse like your BigQuery, your SQL pool or your Snowflake, whatever database you want to use. You can use your Postgres, but this DocDB, for testing sake, we can use DocDB because it is relatively easier to spin and is an in-memory database. So what we are doing is we are passing in the Python generator that we have here. This is for the stream process, while this is for what's it called? Not this. This right here is for the batch process. So what you would see is simply, instead of having to run your data pipeline on a daily basis, you can run your data pipeline on micro batches, which means at every time the data is generated, every 5 minutes, you can be fetching like 100 rows. So DLT can help you manage the numbers of rows, or use it as like a package that helps you generate like how many numbers of rows should be extracted from your source data without running into an error or without running into memory loss. So at every point, DLT can help you decide that, so you don't run into a memory loss while pulling your data. So we are passing this Python generator, which is that paginated getter that we are using to extract our data from the source. We are passing it into this DLT pipeline, and we are also passing our stream data into this. So we are using a write process of replace. So this pipeline is usually custom in such a way that you can use whatever write method that you want to use, whether you want to use a replace method, you want to use a merge method, or you want to use an append method. So you can easily put that. That's why we said earlier before that it helps you build your data pipeline 5 times to 10 times faster than how you want to build your regular data ingestion pipeline. So it's customizable in the sense that you can put your write type, you can specify the numbers of rows you want to be writing every time you are pulling your data from the source. You can do all sort of data injection manipulation using your DLT. So right here we are right here we passed in our what's it called paginated getter script that helps extract our data in micro batches, and we also pass in our stream pipeline that extracts our record row by row in real time. So I can come here and run this. You can see the way your data is being extracted. So it's picking the data from the source page by page, not that you are loading all your data at once. So with this, as it's pulling this data, is loading it into DocDB destination table page by page. So this is an alternative for you to just bulk load your data. So you can extract your data in micro batches, which means you can be fetching probably 1,000 record every 5 minutes when you are working with a very large source data. So it's finished running. So right here, this is your DocDB. Basically, you can set connection to your DocDB to query those same data that you just loaded. So I can come here, right? This is where we set our connection to DocDB. We import DocDB library. I already explained what a DocDB is, which is an in-memory database. Basically, you can use it for your development pipeline before you move to production. And it's easier, relatively very easy to spin up within your Jupyter notebook or whatever script you want to have it running in. And you can easily perform your SQL in order to test those different tables that you have loaded. So right here, this is showing all tables that we have within our DocDB database. So right here, you can see the table we just loaded, which is HTTP download. This is what we have in our pipeline. So this was the first table name that we loaded, and this was the second table loaded. We loaded this one in batches. We try to stream this data into our database. So if I come here and run this basically, so you see the different SQL statement that brings the data I have from my source system, which is, so right now what I'm doing is I'm querying my database to fetch the data. And this is showing, this is a taxi trip data. It's showing the latitude or where the trip end, latitude and longitude where the trip end, the fare amount paid, the numbers of passenger carried, the payment type, the starts location, trip amount, and all of that. So this is bringing in my record. Then what you see right here is another record. So it's same record, but we brought it in with a different approach. So it has a start time, end time, vendor, and all of that. So the next thing we want to look at is normalization, right? So I made mention of the fact that when you have a nested JSON file, DLT can help you unnest such file. So in the sense that if you have your data source coming in as your data coming in as a JSON format, it can help you normalize those data. It will help you pass or flatten those list or nested JSON file and help you standardize it such that you have your data in a desired or usable format. So we already talked about all these, inferring your schema, alert changes on your schema, and using schema as data contracts. So you can use it to detect data type correctly and all sorts of different advantages that you can use. So let's assume we are importing our DLT and our DocDBT again, and this is the data we want to work with. So this is data on taxi trip. It has vendor name, it has time. So there's a nested pickup and drop off time basically. And it has distance traveled for the taxi trip. It has a start location, end location. And within this is a coordinate that shows the start time and end time. So this is the rating for the trip too. So the rating, the store, the payment type. So we will assume that, let's see, we will assume that there will be a separate table for passenger because it's part of the list. And we will assume that there will be a separate table for rating. So if I come here, so this already ran, right? So this is setting up the pipeline and telling it to use a destination of DocDB and create a database called taxi rights. So the right method we want to use is merge. And this is record hash. This is basically what we want to use as a primary key. So we want to be able to track the changes in our data. So we have a column that we added into our data set called record arch in order to help us track those changes when we want to merge our data. So if I come right here and run this query to query what I have in our database, so to query what was loaded inside our database, so come back here, this is the data set, this is the table name. So we pass in this data here, we pass in this data into our pipeline in order to create this table. So you can see how fast it was. This is the data here. This is the pipeline setup. And what we just need to do is pass in the JSON data here, pass in the table name, the right method. We don't need to write any complex script, just pass in the right method and tell it what primary key it's using in order to track changes. So we are saying the primary key will be the record hash, which is this distinct value for each row here. So now that I run this query, so what it returned here, firstly, this is showing me all the tables. Then this is showing me what I have in my first table. So typically what I said is we have a first table that stores information on ride. So first table name is ride. So it's automatically help us within this data, it automatically help us create a separate table for this and a separate table for passenger. So this passenger, we can join it. Passenger table can be joined to this or this up here. And this rating should be able to join with this. So passenger table should be able to join to this one up here. Then let's take a look at what the resulting table looks like. So typically, this is our first table on ride. So this has the start time, end time. So what you notice is this coordinates is this latitude is nested within this start column and within this coordinates column. If I go back to my JSON file, you see it right here that this is nested. So let's go to coordinates here. You can see we have longitude inside start time and inside coordinates. So it helps us flatten this. It passes through this data and help us create a single column that has the coordinate underscore start underscore longitude and also coordinate underscore start underscore latitude too as well. So if you come back here, you can see on your column, this has been normalized. This has been normalized. You see your payment. You see payment underscore surcharge, payment underscore strip. These are probably nested data that was flattened for us. So right here, you have another column here. So what you notice is this is storing information on passenger. It's storing passenger information, which is passenger name, rating, and all of that. So this is also within the lists. So it helps us automatically generate this as a passenger table. If I go here, you go to this table here, you see passenger. It has this information right here. So it helps us create a separate table for this. Stops has this information right here. So if I come right here, I'm seeing my passenger, I'm seeing my stop, which are the two other columns that was created, two other tables that was created from this data set, passenger, stop. So basically, it's expected that you can join your passenger with the fat table, which is the right table, and you can also join your stop table with these two table up here. So if I come here, you can see how can we join this table? We can join on this parent ID right here. So this parent DLT parent ID will be joined on this ID here, this DLT ID. So DLT ID is getting joined on DLT parent ID. You can see it's the same value here. So if you join this on this, you have all your record within this table. Then if you come here and come to your stop table, you can join this parent ID to your DLT ID here too. So you can either join here or join here in order to have a single table for your JSON file. So you don't need to be writing multiple scripts or trying to investigate the JSON file yourself. Everything is right here in your tables. Everything is typically just normalized on your table. So this is where we try to join those multiple tables using select star from ride, join the passenger table, then join the stop table. What are we joining on? We are joining the DLT ID on DLT parent ID. Same thing goes for the stop. We are joining the DLT ID to parent ID too on the right table. So this table then, this can now show for each passenger the different rides or the different trip each of these passengers have taken, and also there are different stops after joining the table. There are different starts and stop location. So you can see how DLT can easily help you normalize your data without having to spend much time trying to investigate your data yourself in order to see what is nested and what is not nested, or without having time to write, without spending time to write some different complex scripts. So these have been developed for data loading itself, and it's like you can see it as a one-stop shop for data loading. So it can connect to different source system, and it also supports a lot of other destination system. Then for your incremental loading, basically, you can use DLT to incrementally load your data. So what this means is, so right now, let's say the record has changed. So let's say something changed within this data. We have a record hash here that help us track the record. Let's say this changes, the status changed to cancelled. And what did we have in our former data here? We have status as booked. So in our new record, it changed to cancelled. Let's see, what else did we change? So let's just track that for now. And I think there are other things we change, which is rating. So rating here is saying 4.4 for John, Y for Jack 3.6. Let's see the rating that we have here. So rating here for John is 4.9, 3.8. So we want to incrementally load this data such that it doesn't read all data from the sources and just insert it into data. It has to come here and just check if this data exists. Then if exists, match the record so that it only updates the values here rather than just bringing a new role or rather than just having to load all your data from the source system. So if I run this, so notice how our write mode, we are using match mode and we are stating our primary key here. So this is all what you just need to do. Set it in your pipeline and tell it to use a match node. And mind you, okay, now we have our new record. So what you just see is John's record. So we are reading our data from docdb again. We are selecting from the right table. We are selecting from passenger table and stop table. So what you realize is the data didn't duplicate, but this now has been updated to cancel. The payment status have been updated to cancel. So if you look at what we had before, we had payment status as booked. So this comes here to update your record to cancelled. And it also updates your rating to from 4.9 to 4.4 and 3.6 respectively. So if you go back here, you see what the previous rating was. The previous rating was 4.9 and 3.9. So this gets updated into 4.4. This get updated into 4.4 and 3.6 basically. So what's next? What next? So these are other scripts that shows how you could load into other database systems. These are different templates you could use. So right here, this is saying when you are working with a package file as your destination rather than docdb, how do you load this data? So you can use this template and specify the destination, which is going to be a file system at this point. So what you are doing is you are specifying a destination whereby you can load your data in as a package file format. So regarding where you want to load into, whether it's BigQuery, whether it's on a package file, so whether you are loading into a data warehouse, there are different source systems that DLT support that you can go through. So any questions so far? I have like a mini project I worked on. I would like to walk you through. All right, so this is what my environments look like. As you can see, I have a Docker Compose file, I have a Docker file, I have a package file here. I have like a data lake here for what's it called, storing my file. So what you see here is if I try to open my Docker file, I'm supposed to like use my what's it called, VS Code, but I'm guessing the screen might be too tiny for everyone. So this basically store information for storing, setting up my Postgres environment. So in this case, rather than using docdb, we want to what's it called? We want to use a Postgres environment as our destination environment. So right here, I'm mapping the place where I want the data to get stored. I'm having my root user here, and this is my port here. 8080 is connected to the local environment is connected to the Docker container on port 8080 against port 80. So yeah, this is my PG admin environment, the email and the password. So what I want to do here is also I have a Docker file for my Python scripts as well. So for this case, let's just use our Jupyter notebook. So if I open my Jupyter notebook, what you'll notice here is I have different setup here, different library here. This is my request library. This is my PyArrow, which help me like work with my package file, because the data I'm extracting from the what's it called, server, or the data I'm extracting using the API is a package file format data. So I'm working with New York taxi data, which is a free data set available online for different taxi trip in US. So it's similar to the Uber we have here. So what we have here is the pandas for manipulating data, IO for interacting with my file, DLT installed, and OS to interact with my computer itself. So first thing I want to do is I want to run a request.get. So in this case, I'm defining a function, and in this function, I'm defining the size of data I want to be pulling um, at a time or at a go from the different data source. So you could specify 1,000 row, I could specify 10,000 rows. So this is basically pulling chunk size of data, 1,000 row is taking in the URL and is taking in the output part. So what I do is I fetch this data using the request.get, check if the response is 200 in order to continue. If it's 200, that means it's good. Then I go ahead and use this IO to let my, because it's pulling these requests, this request is returning like an object. So I want to be able to interact with this response content as a file rather than an object. So I pass in this command in order to make me interact with it as a file. Then from here, I can set up my directory, which is my output part where I might want my data to be stored. Then this is a package file. This helps me to read my data source as a package file. So from this file stream, it's helping me read as a package file. I have pq.package file. Then what this is doing now is this is processing in batch. So it's passing into the chunk size here. So it's using what's it called? Iter batch to iterate the package file in batches. So it's picking row group of those files. Then output file is, so it's telling me, it's defining. So what I'm saying is it should print out what's it called? Where the file is getting loaded into. So the file name and also where it is getting loaded into. So what you can see here is, so for each batch that is getting processed, I'm doing some transformation within that file. So instead of transforming all my data at once, I'm transforming in batches, right? So as it's transforming in batches, it's then loading my data directly into a destination table right here. So you can see data frame. So for each batches, I'm iterating through these batches of file. Then I'm iterating through this file in batches. Then I'm converting it to pandas. So it's in package dots. It's in this format initially, which was package dot, what's it called? Package file. Then I'm iterating this, what's it called? I'm iterating this with pandas, whereby I'm doing some transformation and changing different data type and writing my result directly into an output location. So what I can then do is, for those different parameters, I want to pull data for this year. So in situation whereby I want to bring in data for incrementally, I won't be loading for just this year. I'll just be loading last 3 days or last 4 days data or last 1 month data. So in this case, I just want to load in these 2 years. Then I'm saying for this range of data, because we have 12 months in each year. So for each month, pass through each year using this URL. Then inside this URL, I'm passing in my year and months here. So it's going to each URL in order to return my data. So for each of those URL, it's then run this, what's it called? This Python function that was defined here for each of those URLs. So it's running it against this. So the same thing goes for this other set. These are two data sets. This is yellow taxi data set and this is green taxi data set. So you can see how it's showing how the data is loading batch by batch rather than loading all at once. So when its data is not available, link not available, because probably for that 2024, we only have months up to October or September. So all these other months here are not available, so it doesn't run. So that's basically what this is doing. And there are other scripts here that basically, so this script here, this other script here, what it does is the file that has been written here, it just fetch in the different file paths and append all the file part of that part. So I can have these multiple file paths of my data set in my computer. So for all the files I have injected, these are all the file paths to all the package file. So you can see how I partition it, partition 018, partition 019. So different partition of data. So partition 007, different partition of data. So I have all these parts. So what I'm doing then is I'm now iterating through each of those file paths and loading it into my database. So this is where DLT comes into play. So I have this function that I've read here. This function has the chunk size, it has the package file part, it has the batches of data I want to bring in, then it's converting to pandas in order to transform. But notice this is yielding the data. So I'm not loading the data in memory. I just have this defined such that it yield this result. So what this means is it only fetches the data batch by batch. So I can then come here and tell it to yield from this data defined here. So I'm not returning any list and I'm not appending any of those files. So what I can then do is after defining this is a template for DLT in order to load into Postgres environment. So this is a template that defines the pipeline, specify the database name in my taxi pipeline, specify the Postgres destination, and also specify the what's it called? It specifies the pipeline name, it specifies the database name, and the destination, which is Postgres. So then it runs this. So what you see here is the name of my folder basically is what the destination table will take. So what this does is for name in main, it runs this. So it's when I run this pipeline, it loads directly into Postgres environments. So let me see if I can open. So this is what the output directory looks like. I think I redefined this code in order to make this my data lake. Let me see if I have a different script right here. So this is, let me go. The data lake, this is having for green taxi data, the year, you can see how the path is defined, and this is having folder for the month, for each month. So each month has different partition of data in Parquet. So this was the strategy I used for loading my data. If I come to yellow taxi, I think yellow taxi is much larger. So if I go to 1 month, you can see how many partition of data this is. So if I try to load this as one at once, this might be too heavy, because let's say 1 month having 1 million records or 10 million records might be too large. So this is loading in partition. I can go back here. So this is basically the extraction phase from the data source into my data lake. So I just take this file part as my data lake. So the next phase is loading into Postgres. Let me see. So I think I have this defined here. Okay. So this is just the same script copied to this place. So this is showing the entire process whereby data is being loaded into the destination. So if I had my Docker running, this is meant to show me my Postgres environment. Basically, if we're working on, what's it called? Working on VS Code, I can have my Docker running, then spin up the Docker compose file whereby my Postgres database will just spin up within the Docker environment. So this is where I define my Postgres environment. Then best practice is to have a separate Docker container for your Python script rather than just a notebook, and have it communicate directly with the Docker container where you have your Postgres. So this is how you can use DLT pipeline to read package file format from your API, then load it into your destination table. Load it into your destination table, which is Postgres destination. So this is where I specify the different credential for my Postgres in order to run the scripts. Let me use this here. Let me try running this.
Ella.
Hello?
Just be conscious of time so that you can have enough room for questions. We have just a few minutes, about 30 minutes left.
All right. So I think that might take time to run. Let's just start taking the questions now. So someone asked for the Google Collab link.
Okay. Do you want us to take a question now? Are you done with demonstrating what you want to do?
We can take the questions now.
Oh, okay. All right. So thank you so much, Ayala. So we just quickly run through the question, then maybe I'll just add one or two things to what you have been said so far. So I'll just help you with calling out the question from the chat to make it easier. So somebody's asking, does DLT offer scheduling like Airbytes?
So DLT is not an orchestration tool. This is what I want you to know. Is a data injection tool. So what you just need to do is whenever you have your script running, you can pass it into your pipeline. It could be your Airflow pipeline, it could be your Mage pipeline, and run your DLT script within the pipeline. So it's basically for data injection. And what I will try to share with you also is how you can move forward from what has been explained so far. I don't know if you are still seeing my screen, or have I stopped sharing?
I can see your screen.
Okay, so I'm going to copy this link where you have DLT documentation. And DLT, you said you can see my screen, right?
Yes, I can see your screen.
So I'll send this documentation. I'll send this Google Colab link, and I'll also share you. So there is a link to. Let me share my slide again. So basically, right here, where do you go from here? So this is a DLT documentation right here that you can use to get different documentation on how you can ingest your data and pass it into different source. And this is a material for the previous DLT workshop that has been taken by DLT themselves. So DLT typically is not an orchestration tool, is a data loading tool. So it's primarily for data loading. It's like a one-stop shop for data loading.
Okay,
So what's the
thank you
next
for
question?
thank you for answering that, Ayala. Okay, so in the DLT way of loading data, so is the data paginated as is and batched process, or device is the case?
Is the data what?
So I think what this person is trying to say, just to rephrase it, is this person is trying to say trying to ask how DLT approach data loading. So this person is asking if the data is paginated as is and batch processed when loading data with DLT, or reverse is the case.
So when you are trying to load data in DLT, you can load your data in real time and you can load it in micro batches, basically. So it's usually you pulling your data in micro batches or you are streaming your data in real time.
Okay, I'm not sure if this answers this person's question. We can signify Coca Usayo. So if that question is not answered properly, so that you can rephrase your question. But what I understood by your question is we are trying to confirm if DLT paginates your data and batch it when loading from source to destination. Yeah, from my own understanding, that's the case. So DLT will try as much as possible to batch your data ingestion to optimize resource and improve your performance of data loading. So, but if you have further question, you can signify and you can ask your question verbally. So, so I'll move on. So, does ELT comes with DocDB?
So it doesn't come with DocDB. You have to specifically import DocDB. You can, so there are basically library for DocDB. DocDB is a separate library on itself that you imports alongside with DLT. So you can install your DLT alone without having DocDB, or you can install your DLT with DocDB as well. So that's why I use a sample that has to do with loading into Postgres environment itself. So DocDB is like a database that you want to like run in memory for testing. Same way you want to run your Postgres too as well in order to load your data into Postgres. So
Okay.
it's different too.
Are you done, Ayala?
Yeah, I'm done.
Okay. Okay. Thank you so much for answering that. Yeah. So, for another question, but I think you've answered that as part of this one already. So, can we run this on our local Postgres SQL? So, I think that has been answered. Or do you want to add anything to that, Ayala?
Yeah, you can run it with your local Postgres. You can run it with numerous sources, different databases, different warehouse. Connect it into your cloud data warehouse like your Redshift, your Snowflake. So it supports multiple sources, basically.
Hmm. Okay, so for those that are asking for the link, so I think the link has been shared already. If not, you get link to all resources and that will be communicated to you via the community. So another person is asking, so how does DLT flattens nested JSON files? So does it do this automatically, or there are other processes involved?
So it's help you do it automatically because there are
Mm,
underlying code that is running beneath DLT that help you run that. So you don't have to do that yourself or manage that process yourself. I think I specifically demonstrated that and I didn't have to pass any parameter in order
mm.
to help me pass the JSON file. You just automatically pass it for me.
Okay, yeah, thank you for answering that. So the same person is asking, so does DLT works for any magnitude of data? Can you use DLT to
Magnitude
ingest any
of
magnitude of
data, you
data?
are saying in terms of size of data? Absolutely.
I believe so.
Absolutely.
Um, okay, but I think that there might be a condition for this, right? Maybe it depends. It depends on your definition on the definition of magnitude in terms of size, in my opinion. So
So the way DLT works is DLT makes it easy for you to scale regardless of how large the data, and whatever memory you are working with, it helps you. Like that's why I explained the term of micro batch processing, whereby you could have data that is being generated by your sources and is being pulled like every 5 to 10 minutes, and certain amount of records are being pulled, which means you won't run out of memory. DLT can specifically help you manage the size of data being pulled at a time so as not to run out of memory. So when you are working with large amount of data, it allows for that throughput, or it allows not for your memory to run out pulling those large amount of data.
okay, so we don't flog this too much. Move on. We can always explore this and research more. And the person that asked the question, you can also research more on this. Even though personally, I believe it depends on the magnitude of the data. DLT might not scale well for some size of data. Data guide, is it in response to this one? You can go quickly.
So it's a question and probably a response at the same time to the other one. So I think DLT can scale. It doesn't matter how big your data is. Right.
Okay.
So that's one. Then number two, I want to ask a question. How does DLT do like data? You are trying to move, not an API now. You're trying to move data from one database, like you're moving data from your source, your OLTP source to your OLAP. And if it's doing that, does it just do the regular insert? Does it do a bulk upload? Does it go into the bin log, your uplog? Can it pick data from that point, or is strictly just using a cursor on the surface to do its thing?
So if you notice what I tried to do, I started with a Python script in order to connect with that data source. And that Python script is what is being passed into the different, what's it called, the DLT pipeline itself, in order to generate the data in micro batches. So since you can typically use your script to interact with those sources, those LLTP source, you can create a Python generator function that can pull those data from those sources and pass that function into your DLT pipeline in order to load data from those LLTP sources. Does that answer your question? Hello, is data guy still there?
Yeah, it's okay. Yeah. Thank you.
Okay. So we'll move on. As regards that. This one has been answered already. Can we use DLT to connect to different databases? Yes. So another person asking, can we use Airflow or Airbyte alongside with DLT?
Yes, you can use Airflow. You can use different orchestration too alongside with DLT, because it's typically a script. It's a Python script. DLT is a Python library, basically.
Yeah.
So far you can run your Python script within those orchestrator. You should be able to use DLT within it.
Yeah. And to this person, so Airflow and Airbyte are doing these different things. So Airflow is orchestrator. Airbyte is more similar to DLT, which is usually for your EL. So, but yeah, thank you for answering that, Kudus. Just checking through. So another question, does DLT serve as staging for data ingestion? I mean the in-memory database DocDB.
So like I said, DocDB, yeah, you can use it for staging basically before loading into your data warehouse. But basically what we use it for in this space is to test. So regardless of what way you want to bring in your data, I'm not sure if that question is clear enough, but then regardless of how you want to bring in your data, whatever location you want to stage your data before transforming it, DLT is just there to ingest those data in that environment. It could be your staging environment you want to have those data first. So DLT can just extract that data and put it in that staging environment. It could be your DB you want to use for staging. It could be your Postgres you want to use for staging. DLT is primarily extracting or loading your data, nothing else.
Okay, so DLT is basically an EL tool, extract and load tool. Okay, so DLT makes the pipeline more reliable and scalable on the data ingestion parts, right? So this person is asking if DLT makes data pipeline more reliable and scalable.
Yes, it makes
I
it
think
more reliable. It makes it follow some specific rules, help you enforce schema information. It helps you standardize your data. It helps you flatten your data automatically. So it's just seamlessly is a one-stop shop for data injection. It helps you properly manage your data and makes it really scalable.
Okay, thank you for that. Okay, someone's DLT itself is like airbytes. So I don't think this is a question. So okay, I think this is in response to
So
somebody that
one
was
thing I
asking.
could say about the airbyte is you use your airbyte for loading using the different UI. So DLT personally is more customizable in the sense that you can customize it within your Python scripts. Is way more customizable rather than just interacting with those different UI. It's very much customizable and flexible when you are injecting your data from the source.
Okay, yeah, I think yeah, I think this data guy was responding to that person that's asking if DLT is the same thing as Airflow or airbytes. So I think we've answered that already. Any other question from the audience? You can signify to raise your hand, and we can quickly have a question. Any other question from anybody? Okay, any contributions? Are there any things you want to add? Any opinion you want to? Okay, Rashid, go for it. Rashid, your mic is muted if you are speaking. Okay, any other contributions? Any question, any opinion to add? Any clarification needed? Rashid, your hand is up, but you are not speaking. I've asked you to. I can't unmute. Are you serious? Let me see. Let me unmute you. Can't unmute you. Okay, I think you should be able to unmute. Maybe it's from your hand. I think we have people that have spoken before on this call, so maybe it's from your hand. Okay, if you cannot unmute and there is no other question, so I would just like to, thank Kudus and just add little things.
So
So the first, okay, Kudus, you want
one
to say
more
something?
thing. I don't know if you want this if after you are done or before you are done. Like the merge, I have a question and
Oh,
anyone could
okay,
stand a chance
okay.
to win
We
a
can do
data
that for the
engineering
last,
merge.
for the for the bye-byes. So now I just quickly want to add in a few things. I mean, just like contributions, I mean, and to just summarize everything. So especially for beginners on the call, because I can see many questions are really beginners question, which is fine. We are all here to learn. We are all beginners. So if you are not beginner, we won't be here because you are beginners because you want to learn, and that's the mindset we want to have as professionals, especially in data engineering. So which is fine. So I just want to say that the first level of earning knowledge is awareness, which is what this session is about. So please don't let it stop here. Make sure you, after this call or anytime you have time, make sure you set aside time to explore, to understand more what DLT is all about. So DLT itself is a relatively new tool. I think it was launched maybe sometime last year, I think. Yeah, and started gaining momentum this year, and people have started talking about DLT. And like Kudu said, it's basically just EL2, which is extract and load, which is one of the processes in data pipeline. So you, as a data engineer, are usually required to move data from different sources and load it to a destination to make the data usable for downstream users. And the critical part of doing this is EL, because if that part is faulty, if that part is not fine, trust me, there is nothing that can happen downstreams, because if the data is not ingested or ingested properly, it's all things that have been done wrong there, that will flow through to the entire pipeline, that will cause issue. So there's some EL2 that already exists even before DLT. Somebody mentioned Airbytes. So Airbytes is an EL2 as well, which is well known and well adopted in the industry. And usually when you see tools like this, so they are usually tools. That's why I used to tell people, tools are just there as a means to an end. So the real thing you should know is the ingestion, and any tool can then be used to perform this ingestion depending on your use case and the environment. And at high level, like I said, DLT itself comes in place to bring in some benefits. And one of it is really the open source, which means license is not required for you to use DLT as an individual, as an organization. So it removes that cost barrier. And it's also very resource light, like Kudu said. So you don't really need to provision independent or specific infrastructure to run DLT. So you don't need to run services in containers and stuff like that to really use DLT. So it's as simple as, pip install a Python package into your code, and you can start importing DLT and start using features of DLT, which is really good. So it also means for we data engineers, we are always accustomed with Python because it's Python based. So it means it gives you that level of customizability, that level of simplicity. You don't really need to learn too much or learn another tool, another code. You can just, install, import, and you can start using in your pipeline. So it has a lot of features anyways. So I just want to mention some of these which I've done. So incremental loading is one of them, schema, automated schema evolution. When things change in source, it can automatically adapt to your destination. And a lot of things Kudus has mentioned. So in summary and at high level, what we are saying is DLT itself, it's a tool for us to achieve EL side of data pipeline as data engineer. And the really way you can really maximize this is to actually practice. So once we have those links and those results from Kudos, we are going to share it. So please do check it out. Also check the documentation itself. That's a single source of truth that you can find everything. And we can then collaborate, ask questions in the community, and can all learn and improve together on this particular skill set we are acquiring today. So thank you so much, Kudus. Thank you for hosting. Thank you for sharing your knowledge with us. We always appreciate. We're always willing to learn. Yeah, so we appreciate the efforts put into this, the time you spent in documenting this and compiling this for you to share with us. So really appreciate it. So if there are no other questions, I will allow you to ask your question, and I'll be looking forward to see the winner of the giveaway. So thank you so much, Kudus, once again. Thank you so much, everyone, for joining. So Kudus, over to you.